Everybody, my name is Laura Boschis, as you know, and I'm the responsible of Trustech. That is a society, a private society dedicated to R&D. Our work is organized in part of in a building in which we have a laboratory for biotech, and in another side that is close to the same, in which we have a clean room. Trustech usually work with other partners to develop new ideas and then try to find funds to develop new startups, new projects, and so on. We start from the feasibility studies that comes from example from ideas coming from a university or other research center, much more dedicated to the research-based research, and then bring the idea, the project, just to the industrialization or the engineerization industrialization. We are specialized in. We are a group of multidisciplinary experience with multidisciplinary experience, but basically we are expert on material science, chemist, and engineering in general, or biology. Our customers are essentially universities that want to bring their idea in a upper level, then or IoT companies, or at least big industries that needs some major effort to develop their own research. We have the possibility to help them to the technology transfer in order to link, for example, academies to big industries or IoT in general, and then we give them the possibility, some studies for the industrialization. In our lab, we have the base equipment to work silicon in principle. So we have a clean room in class 1000 or 100, in which we can realize electronic devices or single step for the process, technological process. We are equipped with, we have a laboratory even for biology, and so we are able to realize biology sensors or something that can transduce a bio input in an electronic analysis. We have the possibility to deposit materials, thin film coating. We can etch the surface both with the dry wet, then wet etch. Then we can realize photolithography in order to obtain a pattern up to 1 micron. And then we have a small capability to characterization. But we have to say that most of our characterization are realized with in the academy close to us. Here, just to give you an idea of our device, of our laboratory. We have optical lithography, two of equipment of optical lithography, and then we can work just 6-inch wafers. And these dimensions are possible with all our equipment, not only for the photolithography, but also with the thin film growing. And then how we work. Usually we are a collector of problems, in the sense that people arrive to us asking help to find new solution. Then we can analysis. We start with an analysis of the problems, find eventually the right partners to develop to solve the problems, because not everything is solved by us. And then we start with a research process that hopefully arrives to the solution, or at least to an upper level of the problems. In Trustech, we utilize the research to develop new electronic devices, or and that, for example, sensors, thermal sensors, electrodes, in which we can realize the membranes or electrode over membranes and something like that. Or we can realize new surface in which properties are changed thanks to patterning that we obtain on the surface, even with nano patterning. But in this sense, the nano patterning is realized with some treat, like, for example, we overpose on the surface nanoparticles, and then we etch the surface in the interspace between the nanoparticles or something like that. And in such a way, we obtain new properties on the surface, both as to be useful for example, as sensors, or useful, for example, for optical properties, to obtain new optical properties, or to obtain antibacterial or self-cleaning surfaces, and so on. We work usually with other partners. For example, here we can show a pattern that we obtained for the ASI, ASI, that is the aerospace agency, Italian agency, to obtain a particular membrane to obtain sensors for excitation particles. We work also with microfluidics, and we grow our experience in the last 5 years in microfluidics, in order to have a preparation before the sensing side of our lab on chip. And we solve some problems with the industry close to us. That means that we are able to create for them new possibilities to monitor some models, some bases, and so on. Just to give you some ideas, we are able to realize, and we realized for our partners, our customers, sensors online, for example, to detect particular concentration on industrial bath of tensioactives, or, for example, pH test directly online, in order to detect the condition of industrial galvanic bath, and so on. Or we some solution, the concentration of primers to print on can, to drink food industry. And other case, a little bit much more complex, in we put more than one sensors together. We define the condition to detect, for example, how a solution, the condition of the solution may change the workability during the day, in order to be able to have always the better condition. And in particular, in this image, you can see an optical system in which we put a microspectrometer close to a conductant analysis and the pH analysis, and then we perform all the detection of the condition of the bath in the first condition and the best condition in order to link together all the possible changement of the parameters, and then in such a way directly the operator directly in the plant can detect or can check if the bath is in the best condition or not. These are something other experiments that we done always in food industries, because we began a good collaboration with the big packaging industries close to us, and they had problems on the plastics, but we work also in medical devices, and we define, for example, for an important diagnostic close to us, a condition to detect the thermocycle of a PCR, of their own PCR, defining a device in which the parameters are a device that is useful for their instruments to monitor the work of their instruments. We are very open to every kind of new ideas, and we are open to a lot of new projects. For example, now we are studying new solution to maintain clean in hospitals, in particular realizing new nano patterning on the surface in order to obtain what is called the cicada effect, but in a big area. And with in the same process, in the same project, we are developing even new techniques to detect the surface optical trick, just to define correctly and even far from the laboratory if everything is going well. Then we developed one project by ourselves that is a platform to realize in point of care immunodiagnostic analysis, and we called it ELICHIP. And ELICHIP is a device that can detect small amount of surfaces, realizing an ELISA protocols directly on site, obtaining quantitative analysis with the same quality and accuracy as the ELISA of the laboratory. And in this way, we are going to work hardly in this next period. And then we are involved, just to give you the idea of other projects that are open now in Maria Sklodowska, in a Marie Curie action, in a PhD school that is called Premurosa, and that is in medical application for the study of surface of implant surface for bone surfaces or implant. And then we will start right in next January a new project that is called Flamingo, in which our device that I mentioned to you before, ELICHIP, will be used to detect on an organ on chip markers of arthritis, rheumatoid arthritis on knees. And more or less this is all. These are a list of our partners, and I hope that everything is quite is clear, and I'm open your question. Thank you.
Okay, thanks, Laura. Thanks. So I think we have time for some questions. So we have some questions from the students of the PSRS. So the first one is from Natalia dell'Agustina Balman.
Yeah.
Yes, that's me. Thanks for your presentation. I would like to ask, how long did it take for you to establish the company, and which was the first expertise you worked on? I see that you presented a lot of things related to biotech and also to electronics.
The beginning of your question is not clear. Sorry, because it was a lack of the communication. Could you repeat?
I asked, how long did it take to establish this company?
Okay, 10 years, more or less. We established Trustech in the 2008, but in the first years, we were just only a technology transfer office. Then after 4 years, we got the laboratory and we begin to be an active partner in our project. And we begin to work at the very beginning. We start with the with public funds projects, and then in such a way we begin to create our network. We were to the Polytechnic of Torino, so with them we share some projects, and partners of project became after sometimes our customers.
Okay, thank you for your answer.
Yeah.
Good. So, so next question from the student is from Mohamed Amrazou. Is it?
Yes. Okay. Good morning. Good
okay.
Afternoon.
Good.
Good afternoon.
You talked in general about some examples of the problems that you solved, but I still don't understand completely how the micro devices are exactly made. Could you please talk about the most common techniques, or explain some of the devices that you made in these examples in more details?
Yes, sure. But it depends. Each kind of device could be realized with different techniques. But of course, having the building blocks, technological building blocks to realize to micro patterns surfaces, we can start with the photolithography, for example, and then create. Protect where we want to protect the surface, and then etch the free surface, or at least deposit on the free surface thin film in which you want, for example, to obtain electrical conductivity, or if you want to etch to obtain engrave surfaces, and then it depends on the device that you want. But for example, if you want to obtain MEMS, we can deeply grave silicon, leaving just a membrane, a thin membrane on the surface, in the top or in the bottom of the surfaces, in which you can create, you can realize electrodes, you can realize just to take information, or you can put piezoelectric materials, piezoelectric systems, in order to have or a mechanic answer or an electrical answer. It depends. It depends from a lot of things. Or for example, you can nano-patterning the surface in order to have different, according to the stress that the surface will have, different optical answer in order, and then you can have an idea of if the surface is flat, or is a certain curve is realized, that could be due to the presence of difference of atmosphere or different of stimulus that you have on the surface. We are a fab in the sense that our projects are not realized by us, or at least we work with the people that realize the project, study the feasibility of the project, and then we build the device. So we put the available our equipments in order to obtain the to create the device, and we study if the answer is in line with is coherent with the project or not, and then we change and we go step by step to the creation of the best solution.
Okay, thanks. Yeah, then I think both the students that did question will come to Torino, right, for their semester. So for sure you will understand better. It is a quite long way to explain how you fabricate this device, but you will gain all the needed to say info. And then we are just discussing these days with Laura the possibility to do a hands-on lab in their facility. Right, Laura?
Yes, sure,
yeah.
sure.
So that would be really how to say bridging the gap of this knowledge. Okay, so there is still one question from another student from the PSRS. That is Muluseu Wondi Yaltaye. Sorry if I don't pronounce it correctly.
Okay, thank you. Thank you for precise and interesting presentation. As you mentioned in your presentation, you work with aerospace company in collaboration. And here is my question is, what is your role in aerospace company?
Which are we worked with we had some small collaboration, for example, with the Thales Alenia close in Torino, and then we work with, for example, Argotech, that is another company to Thales, quite close to Thales, and for Avio, we work with the General Electrics. And for them, for example, we realize the sensors that you see, the sensor station to detect the condition of washing machine for engine cleaning.
Okay, thanks. So do we have other question? Okay. Sorry, so the student Muluseu Wondi, are you satisfied about the answer, or I don't hear you anymore? I guess it means yes. Okay, so do we have other question from the audience for Laura? I don't see raising hands.
No.
So I think we can thank Laura. Thanks for joining your expertise here. Thanks. And then we can move. Yeah, we can move to next speaker.